This is probably day 24 of us learning how to build on a blockchain. I have my laptop in front of me and we are going to learn how we can create an NFT collection on the Celo blockchain. By learning how you can actually create an NFT using code, that will further enhance your opportunities to have a blockchain career, whether you would like to work freelance or if you'd like to have a permanent job or even start your own company. We're actually going to create NFTs that represent tickets, and these tickets are going to be for a TED Talk that we are going to speak at in the future, where we inspire others to become a blockchain developer. So we will start off by first creating the tickets, like the graphic for the tickets. Then we'll upload it to a decentralized storage system. And then we will create the code that represents the NFT. Then we'll deploy it on the Celo blockchain. And then finally, I'll explain how NFTs work at the end. You can use this video as a step-by-step tutorial. I'm actually here in my shared workspace. It's a Sunday, but it really doesn't matter. There's no better day to learn to code. To start, let's go to canva.com. It allows us to create the graphics so that we can use it to represent the NFT. So I already created one and this is what it looks like. So just go ahead and download your images. I actually created 5 because I plan to just have 5 tickets for this event. And I downloaded the folder. Next, we have to think about where are we storing these images. There are many places where you can store images on the internet. However, we are going to opt to use decentralized storage from NFT.storage. So go to NFT.storage and sign up for an account. So by using decentralized storage, we're using a distributed network for storing our data, which means we automatically benefit from redundancy and enhanced performance due to geographic localization. When you buy an NFT, you buy the token that represents something in the real world. So NFTs usually have a smart contract, which represents the NFT, but then we also have the metadata of the NFT. So this metadata is normally not stored on the blockchain because storing data on the blockchain is actually quite expensive. So you have to store it somewhere else. Now, if we were to use like an HTTPS link, then we are not guaranteed that the data behind the link, A, will always be there, will always represent the correct or the same thing that we originally bought. Because with an HTTPS link, for example, if I have something like HTTPS Google Drive /dog.jpg, I can easily swap the image and call it the same item. I can still rename it dog.jpg and it can no longer be the dog that I first represented with the NFT. That will be a disaster if you purchase an NFT which gave you access to a particular file, and that file is something that is worth millions. You know what I mean? Like CryptoPunk, for example. So by using IPFS, they use something called content addressing, where the actual link that is generated based on the content that is uploaded at that link. So if the content were to change, then the link will change. Now, nothing is wrong with changing the data that an NFT represents, but if you would like to add that functionality, you'd have to add it to the smart contract level instead of to the actual location level. So the NFT, which is the token, will point to a particular location on the internet that represents the asset that this NFT represents. And we are using Filecoin and IPFS to store it. The website NFT.storage has made that exceptionally easy for us. So all we have to do is upload the images to the website and not have to worry about all of that. So I have signed up for an account and I click files, and they're showing you 2 ways that you can upload images. You can either use NFT up, or you can use the upload button. I have downloaded NFT up because if you use that particular application, you can upload a folder at a time. So this is the application here. I'm going to drag and drop the NFT tickets folder. So that's going to be uploaded. All right, cool. So that data was uploaded. We have an IPFS URL. We do need to do one more thing, which is to describe the metadata. So we have to actually tell the NFT where can we find the image, what's the name of the NFT, how do you describe it. So you're going to create a JSON object file. So if you just go into any kind of like editor. So I created a folder previously called tickets NFT, and as you can see, it has a description, it has the image and the IPFS location, and it has a name of the NFT. Now, yesterday I have uploaded the exact same folder, and as you can see, the CID of when I tried to upload it recently, BAFY Q7BA, is the exact same as what I had yesterday. As described earlier, because they are creating the ID based on the content uploaded, if I was to re-upload the same content, the ID would be exactly the same. So that's really amazing to see. So I have this copied 5 times because I do have 5 images or 5 NFTs that I'd like to create, and you have to create the NFT for each one. So across each of them, they have exactly the same content. The only thing that's different is the exact image location. So I have a different image for the ticket number 5, a different image for ticket number 4. So you can see the files are named 1, 2, 3, 4, 5. You have to name it the same as the token ID because when you are creating the NFTs, they're going to have token IDs. So now we have the metadata, we have the images uploaded. The next thing we're going to do is write the code. We're zipping through this very quickly, so I hope you guys are enjoying it so far. If you have any questions so far, leave a comment down below. The next thing that we need to upload to NFT.storage is a metadata, which tells each NFT where they can find various information about it, such as where the image is located. So again, I'm just going to upload this folder and wait for that to be uploaded, and then it will tell me the content identifier. The next thing we're going to do is actually create the NFT smart contract. So to actually create the NFT, we are going to have to write code. At the end of the day, an NFT is just a smart contract. We are going to use Open Zeppelin because Open Zeppelin actually has a lot of implementations to very popular standards within the Ethereum ecosystem. And one thing that is actually super helpful is they have a contract wizard, which allows you to easily create the boilerplate code for the actual token. So if we start with ERC721, I'm going to name it Z-Talk tickets and then call it ZTT. And the URI is going to be the IPFS link to the metadata. The metadata is required to do other things, not just describe the image of the token, but also give it a name and description. The URI would be the IPFS link created when we uploaded the data to NFT storage. So if I just copy the CID, I could simply put the URI as IPFS, and that's there. I'm going to make it mintable, which means that we can mint more tokens or more NFTs, and then I'm going to auto increment IDs. So you see it already has the code here, and here we make it ownable, which means that only the person who deployed the smart contract will be able to mint more NFTs. So if I just copy that, and now we are going to go to Remix. And Remix is a really popular interface for writing smart contract code, and you can access it from your web browser. So you're going to go to remix.ethereum.org. I'm just going to create a new folder and call it Z-Talk Tickets. I'm going to create a file called Z-Talk Ticket NFT.sol because it's a Solidity file. And then I'm just going to save that code. I'm going to add a little bit more code because I want to make sure that there are no more than 5 tickets. So I'm going to define a variable for the max supply. So I'm going to say uint private max supply equal to 5. So the max supply is 5. So when I check token ID current, that will tell me how many tokens have already been minted. So I'm just going to say require the token ID be less than 5. Because if it's already 5, then we've already minted 5 tokens. All tokens have been minted. And then finally, I'm going to create another function, which is essentially telling us how many tokens we already have minted. So num tokens minted. I'm going to say it is public. Only the owner can call this function because why not? And I'm going to say that it returns uint. Anything else do I want to say about this? Yeah, and then I'm going to say, oh, this shouldn't be 5, this should be max supply. What's the point of creating that? Yeah. And then I'm going to say return this token counter.current. And because this function is only going to be returning data and not modifying anything within the state of the smart contract, I'm just going to call it a view function. All right, so that is done. So we can go ahead now and deploy it to the blockchain. So what I will do is I want to show you guys that the code we're using here can be used on multiple blockchains. So let's connect to the Polygon testnet. So to be able to deploy your token, you need to have a wallet with an account that you control. So I'd like you to download Metamask. You can add Metamask as a browser extension. So go to Google Chrome Store, then search Metamask browser. Then you can take that and then you can add it to Brave. Once you set up your account, you should see something looking like this. Now we are going to deploy it to both the Celo testnet and the Polygon testnet. So to begin, let's add the Polygon network. So let's say add network, and then we just search for Polygon testnet. And we try our best to find an official Polygon website when we are adding these things. So you find the Polygon testnet. So we're just going to fill out the information. So the RPC endpoint is that. Put that here. The network name is Mumbai. Just going to name it Polygon testnet for simplicity. The chain ID is 8001. The blockchain explorer is not located. Okay. So for some reason that one doesn't work. So let's see if I can find another reputable provider. Yeah. Okay. I've used this one in the past. I don't know why that one didn't work. All right, cool. So now we need to also add the Celo testnet. So if I go into the Metamask manual setup, they have something for Metamask and Celo. So they're telling you how you can use Metamask and Celo. And then you can just add the wallet. So Alpha Joris, I'm going to use that testnet, which I already copied. This chain ID. Currency is Celo. And then the blockchain explorer. Let's see. Awesome. So now I'm going to get some testnet tokens so I can fund my Celo testnet account with some Celo tokens, which you get for free from the faucet. It has no real value. It's just for you to use when you are playing with the testnet and deploying things. And then I'm going to look for a Polygon faucet and do the exact same thing to the same address. Awesome. So now we have both testnet tokens for the Celo network and the Polygon network. So now when it comes to deploying, so we can deploy it first to the Polygon testnet. So I can go here, do injected Web3, and say next, connect. Now it automatically detects which network I'm connected to. So first I'll start off with a Polygon testnet. And we can deploy the token, which is called ZTED ticket. So make sure you scroll onto that smart contract. And then let's do deploy. So it's saying unknown processing time because it probably calculated the gas fee incorrectly. So if I just go here to edit and I click one of these, I can get a more accurate time. So if I click low or, for example, medium, then it say, okay, likely in less than 30 seconds to save and confirm. Oh, that's deployed. So now we have the methods here shown and we can interact with the smart contract. So for example, we can mint the token to ourselves. We can check the balance. We can see the number of tokens minted, which is a function that we created. So if I do this, it will say 0. So now if I mint one to myself, I say safe mint. It's now bringing up a blockchain transaction. I'm going to edit it so the gas fee is a bit higher so it can be deployed faster. Yeah, so if I do number of tokens minted, it says 1. If we'd like to view the actual NFTs within our wallet, even though it's deployed to the testnet, we can actually use Opensea. Opensea actually has a testnet version. So if I just search Opensea Testnet, and it's testnet.opensea.io, then I can actually see if I have an NFT within my wallet. So now that I'm on Opensea Testnet, I can then connect my wallet. So connect via Metamask. Make sure you're interacting with the correct website. I also have a dummy wallet while I work on this, so please don't use your real wallet with your real funds while you are testing and doing development. You do notice that there's an error, which is that my images don't load. And we learn better when there are errors because we're more focused. We're like, what? Why did that go wrong? So I'll tell you what went wrong. There were actually 2 mistakes that were made. So the first mistake is when I paste the base URI in, I didn't add a slash at the end. So essentially what happens is at the end, they would add the actual location of each of the metadata required. So for example, it's metadata 1, 2, 3, 4, 5. So a slash like that. So that needs to be done. So that means we need to redeploy the smart contract, but not to worry, we are deploying to the testnet, so we're not spending our funds. The second mistake that was made is that the title of the metadata file has to represent the token ID. And as we can see, the token IDs actually start from 0 because in programming, they actually come from 0. So we need to change this from 1 to 0, from 2 to 1, all the way down to 5. And that means in the code where we say we only want 5 tokens minted, we set this less than max supply. So 0, 1, 2, 3, 4. So we'll have 5 tokens when we reach token ID 4. So if the token ID right now is 4, that is less than max supply. But we don't want to increment that number again because that will bring token ID 5, which is actually 6 tokens. So in this line here, we need to say max supply minus 1. Because I've changed the names of the actual files, I will also need to re-upload this onto NFT storage. It has been uploaded, so the CID will change. So I'm just going to copy the CID. And I'm going to change the CID in my code. Make sure I have the slash at the end. Make sure I have max supply minus 1. And now I'm going to deploy that smart contract. So now if I go back to Opensea and I refresh, so now you can see we have the ticket. You can see the metadata that it's pointing to is now correct. Description is not correct. Ticket to the Web3 stories series. This is the ticket. That's the ticket number. And I even minted myself another token. So if I go back to my account, you can see there's another ticket and you would see it here. So if for some reason the image doesn't show immediately, just wait about like 3 to 5 minutes and it should show. If it doesn't show after that, then there's something wrong with the way you described your metadata for the particular NFT. So now I've done it on the Polygon blockchain. Let's do the same for the Celo blockchain. So I can go back to Remix. And what I need to do is now change from the Polygon testnet network to the Celo testnet network. And it's already connected to that new network. And then I can just say deploy. Cool. So that is now here. So if I paste my blockchain address, I say save mint. Wow, the gas fee is so low. And then I say confirm. That's deployed already. And then if I check to see how many tokens are minted, there's now 1 token minted. I don't think Opensea supports the Celo testnet just yet. So we'll have to find a Celo NFT Explorer. So let's look at the Celo Testnet Explorer. So if I go to Celo Testnet Explorer, just so I can see that the token has been deployed, and I stage my blockchain address, you can see I have a bunch of transactions a minute ago. What is this transaction? Contract creation. This one's a contract call. It's called a safe mint. And if I check here, it says I have an ERC20 and ERC721 token. So that's amazing. So I do have token 0 within the ZTT collection. And if I do the same thing for the Polygon blockchain, so if I do, I think it's mumbai.polygonscan.com is a testnet explorer. I stage for my address. I have a bunch of transactions because obviously a bunch of trial and error. But if I look at my tokens, you can see I have a bunch of tokens. Because I deployed the smart contract multiple times as I was trying to work through the issues, you can see that there are various versions of this NFT. So you have to think about that when you're deploying your NFTs. But here we are. We have NFTs on the Celo blockchain, the Polygon blockchain. This is deployed to their testnet, of course, but we can keep using this code and deploy it to all the EVM compatible blockchains because it's written with Solidity. NFTs, or non-fungible tokens, are unique digital assets on the blockchain. These digital assets exist on the blockchain, which means it's on the internet, but it does represent something unique in the real world. So that's why you can use an NFT to represent a unique image, to represent real estate, or anything else that has value within the real world, but also distinguishable from one another. Since the actual token is stored on a blockchain, it makes it very easy to track ownership, to track the transaction history, as well as to transfer the asset from one person to another. And of course, you're going to transfer the asset for exchange of value, so you can exchange the asset for a payment. Michael, who is a TechCrunch founder, actually sold his Ukrainian apartment as an NFT. It was the first real estate auction, and the way it worked is that the actual apartment was owned by a US LLC, and the NFT gave access to rights to that LLC. So the person who won the auction, they won the NFT as well as the apartment, and then rights to own the apartment. So as you can see from the video, an NFT is actually a piece of code. It's a smart contract which is deployed on a blockchain. A smart contract can represent one or many NFTs, and each NFT is actually identified by something called a token ID, which is just a number within the smart contract that uniquely identifies each NFT. So the smart contract that represents the NFTs on the blockchain, but the metadata about the NFT is stored off-chain, meaning not on the blockchain, because it's actually quite expensive to store a lot of data on the blockchain. The blockchain gives us the benefit of creating the asset, seeing who owns the asset, transferring the asset from one account to another, and seeing the entire transaction history, as well as exchanging value for that asset. And then the actual data that the asset represents can be stored anywhere off-chain, and we tend to use decentralized storage, so that way we can make sure that the asset will always point to the same item and is always available. So now you know how you can create your own NFT using Solidity code, and you can deploy it to many blockchains that are EVM compatible, including Celo. Let me know what you thought about this tutorial, and if you like the style of seeing me basically build live and go through the errors with you, because I believe you learn more from seeing the errors as well. See you in the next video. Bye.